Lesson 7-9 Practice, Part to Whole. Question 1. Jada cuts out a rectangular piece of paper that measures 5 by 4 inches. Han cuts out a paper sector of a circle with radius 5 inches and calculates the arc length to be 2 times pi inches. Complete the explanation to determine whose paper is larger. Jada's paper is 5 times 4, which is 20. And to calculate the area of Han's paper, we have to find the central angle, which is x divided by 360, times the circumference, which is pi times diameter, and that equals the arc length, which is 2 times pi. His circle has a radius of 5 inches, so its diameter is 10. 10 divided by 360 is the same as 136. We take 136 times pi times x, and it equals 2 times pi. We divide both sides by pi, and pi cancels out. We divide both sides by 136, we get 2 divided by 136, which is the same as 2 times 36, which is 72. Once we know the arc length, we can calculate the area. It would be 72 divided by 360 times pi r squared. They said the radius was 5. So you could see his area is about 15.7. All right, so Jada's paper is larger, has an area of 20, while Han's paper has an area of about 15.7. Question 2. A circle has radius 10 centimeters. Suppose an arc on the circle has length 8 pi centimeters. What is the measure of the central angle whose radii define the arc? All right, so it has an arc length of 8 pi. It has a radius of 10. That means its diameter is 20. 20 divided by 360 is 1/18th. And we multiply that times pi times x, and that equals 8 times pi. We divide both sides by pi. The pi's cancel out. And we divide both sides by 1/18th. 8 divided by 1/18 is the same as 8 times 18, which is 144. Question 3. A circle has radius 6 units. For each arc length, find the area of a sector of this circle which defines that arc length. All right, so this first arc length is 4 pi. The radius is 6, so the diameter is 12. 12 divided by 360 is the same as 1/30th. And that's times pi times x, and that equals 4 times pi. I divide both sides by pi. The pi's cancel out on both sides, and I divide both sides by 1/30th. 4 times 4 divided by 1/30 is the same as 4 times 30, which is 120. We use that arc, that central angle, 120 divided by 360, to calculate the area, which is pi r squared. And the radius was 6. 120 times 6 divided by 360 is 2. That's 120 times 36 divided by 360, which is 12 pi. If it is 5 pi units, we change the 4 pi to 5 pi. That means the angle is 150 degrees. $150 times 36 divided by 360 is 15. The answer is 15 pi. 15 times pi. You should be able to see that it is 4 pi times 3 is 12 pi. 5 pi times 3 is 15 pi. 10 times 3 is 30. And L times 3 is 3L. Question 4. Select all the sectors that have an area of 3 pi square units. A sector with a radius of 6 units and a central angle of 30 degrees. 30 divided by 360 times pi r squared. In this case, the radius was 6. And they want to know if it equals 3 times pi, which it does. A sector with a radius of 6 and a central angle of 45. That does not equal 3 times pi. A sector with radius of 3 and a central angle of 60. That does not equal 3 times pi. A sector with radius 3 and a central angle of 120. That does equal 3 times pi. A sector with radius of 3 and a central angle of 180. That is not 3 times pi. Question 5. A circle has radius 4 units and a central angle measuring 45 degrees. What is the length of the arc defined by the central angle? It has a central angle measuring 45 degrees. 45 divided by 360 times the area. No, what is the length of the arc? That is times the circumference, pi times diameter. And the diameter is double the radius, which the radius is 4, so the diameter is 8. You can see that this answer is pi. Question 6. Claire and Diego are discussing inscribing circles and quadrilaterals. Diego thinks that you can inscribe a circle in any quadrilateral since you can inscribe a circle in any triangle. Claire thinks it's not always possible because she does not think the angle bisectors are guaranteed to intersect at a single point. She claims she can draw a quadrilateral for which an inscribed circle can't be drawn. Complete the following to explain whether you agree with either of them. I agree with Claire. In a quadrilateral, it is not guaranteed that all angle bisectors meet at a point. Consider a rectangle whose length is much longer than its width. For a circle to be tangent to the two long sides, its radius has to be half. It has to be half the width, which means it won't reach all the way across the rectangle to be tangent to the remaining sides. So you can see it's tangent to those two sides. It's not tangent to those two sides. Question 7. Triangle ABC is shown together with the angle bisectors of each of its angles. Point D has been randomly placed on the bisector of angle A. Where should point D be placed along the bisector of angle A so that it is equidistant from sides AC and AB, but closest to side BC? Well, it can be placed anywhere on that angle bisector, but to be closest to anywhere on the angle bisector is the same distance from side AC and side AB. It needs to remain where it is to be closest to side BC. Point D may actually be placed anywhere. No, point D should be left where it is. Question 8. Priya and May are trying to prove that if two chords are congruent, they are equidistant from the center of the circle. Priya draws this picture. May adds the perpendicular segment from the center of the circle to each chord. Priya says, I think we should try to use triangles because that is how we proved things congruent before. May says, I think you're right, but how? Should we draw in some radii? Help them complete the proof. Draw radii AO, BO, DO, and CO. You can see that I did that. AO, BO. It made two triangles. These segments are all congruent because they are radii of the same circle. Chords A, B, and CD are congruent because they told you they were. Two chords are congruent. That was given. That is given. Now triangles AOB and DOC, AOB, that triangle, and DOC are congruent by side, side, side. This side is congruent to this side is congruent to this side, and then AB is congruent to DC. Side, side, side. Triangle congruence theorem. The segments that show the distances from O to each chord are altitudes of triangles AOB and DOC. So you can see this segment here is the altitude of that triangle. This segment is the altitude. These segments measure the heights of the triangle. The triangles are congruent, so their heights are equal. So the chords are equidistant from the center of the circle.